EVM along with the Hashgraph consensus mechanism. My name is Essilfie-Conduah. I'm the Director of Software Engineering at Hashgraph, and one of the things I've been able to see out throughout my career is that technology, though complex and with many of its applications, honestly, it needs to just be simple. It needs to work, right? So one of the things that we as builders and even technologists have to keep in mind is it doesn't matter sometimes. All the amazing gains that we're doing, when it comes to our users, it needs to be simple. It needs to work. So some of you may not know about Hedera, some of you may have heard about it and maybe have some misconceptions. So let me highlight. Hedera is an open source, proof of stake, EVM equivalent, enterprise grade scalable blockchain, right? There's a lot in there, but let me highlight some things. Hedera is able to do 10,000 transactions per second natively, right? I am able to choose any of you here today and maybe 10,000 of us could come together and that would go off without a glitch. And this is us throttled. So this isn't our limitations in terms of the technology. This is us just saying that we think 10,000 is okay for now. But every month I assure you that we run tests above this. And we've had companies try and get to this level and haven't been able to yet. So we're quite confident at this part, but we'd love to have you test this out. We also pride ourselves in having cheap transactions. And so you can submit this, crypto transfer for up to 1/3 of a cent, right? We want you to be able to bring your users, and as part of that, it's important to keep the costs low. We promise 3 to 7 seconds of finality. Now, I've given you a range there, and I want to talk about those numbers. In 3 seconds after you submit your transaction, we assure you it will be in the blockchain. It will be part of consensus. You will know for a fact. You don't have to guess and ask if it's going to be included. Within 3 seconds, you will know. Within 7 seconds, you will have a result of your execution, right? So you'll be able to see how the state has changed, all the information around it. And for many developers, that's a game changer, right? You don't have to wait minutes. You don't have to wait on that, spinning clock to go see if it's really in the blockchain or not. And for EVM developers, one really big thing is that it's 15 million gas per second. So we have 2-second block time, so 30 million gas every 2 seconds. But every second, we can support EVM transactions up to 15 million gas. Now, as a developer, again, ask yourself, how many times have you hit that limitation or had to wait? What does it look like when you don't have to worry about the availability of gas for your applications? We also pride ourselves in being really good on the environment, and so we don't only like to say this, but we like to be on the receiving end of independent investigations. So fortunately, the University College of London did a study on many blockchains out there, as well as the Visa network itself, and you see that really small green blob up there? That's us, right? So we are one of the greenest, if not the greenest blockchain, and in comparison, every time you swipe your Visa transaction, we have 1,000 times less energy incentive than that. Some of you may have heard that Hedera is not a blockchain. Let me clarify. Hedera is a blockchain, right? Sometimes what happens is that the definition of a blockchain ends up including things like the consensus. It ends up including things like the actual data structure. Those are implementation details. Those are architectural decisions. But if you think about it, a blockchain is really just a distributed ledger that orders transactions. That's the important part, right? It links them together and allows for anybody to independently verify them using cryptography, right? So again, on the basis that a block is a collection of transactions, sometimes you may have heard in the past from traditional blockchains, right? You'll see what you see on the left here, where the blockchain is moving forward in time, but you have these offshoots. Some people call them uncle branches, uncle blocks, but there's this idea that you could submit a transaction and not know for a certain amount of time if it's going to be finally included in the blockchain, right? On the Hedera side, we group what we call as transactions into first what we call as events, and these are gossiped out to different nodes. Those events are ordered, and then they're put together in a block. And so on the Hedera side, you have this single stream of consciousness, as it were, and as I mentioned before, within 3 seconds, you'll know that your transaction is included. You might ask, how do we do that? How are we so quick? One of the secrets about it, again, this is all open source, so you can check this out. One of the secrets is our consensus mechanism, the Hashgraph consensus mechanism, and part of that is gossip about gossip. And it is what it sounds like. Back in grade school, you might hear people gossiping. We're gossiping about that gossip. So every node is gossiping about what it's heard. So in simplicity, let's take an example of if you look at let's say Dave, right? All of these vertical streams are the consciousness of a node in the network. Dave has received an event from Alice, right? That event is made up of a timestamp of this event that is about to submit, all the transactions that the node is including, and 2 hashes, 2 really small hashes that allow us to do something very magical. If Alice includes a hash of her event and Dave includes a hash of his past message of consciousness, once we sign that and you send that off, you have this interesting thing where the moment I receive an event, I know exactly what you know, when you found out what you knew, and from who, right? And so this hash graph, this data structure you see on the right, is the consciousness of the transactions and the events going throughout the blockchain. And therefore, this is very useful when it comes to consensus, because I'm easily able to say that the conclusion that you came to when we came into consensus is either right or wrong, because I know exactly what you know. You know what I know, right? And we all know when each other found it out. And so gossip about gossip, like I said, allows you to know basically the history of the blockchain. So coming over to the EVM side, a couple of you will know this very comfortably, but let me highlight it for you. The EVM, the Ethereum Virtual Machine, at its simplicity is just a computational engine, right? It's a state machine. What that really means is that with a starting state and a given transaction, I can execute that transaction with some predefined rules and take it to a new state. And at that point, the network is responsible for persisting and making that new state permanent. So in that case, you can see that the EVM should be network agnostic. It shouldn't only rely on Ethereum. You should be able to take this EVM machine and move it to other places. And specifically, Hedera uses the EVM as an execution client, right? So we take in EVM transactions and we execute them within the context of our network. But to me, that's an idealistic view, and that's how I see the EVM and some others. The challenge is that when you're building complex things, you make some assumptions. You don't always get it right. Ethereum has done really great things, but in my view, some of these things should have been configurable aspects of the network. I'll go over some of it. The fact that every time there's a hard fork, you are taking away or adding capability that may no longer be backwards compatible is a challenge for many businesses, right? If you wanted to scale some of the applications that you're building, companies and users might not be on the receiving end really happy that this functionality can be taken away. On Hedera, we pride ourselves that with the features that we add, we continue to make sure that they're always backwards compatible, right? And so we put a lot of thought into this. And so that was one of the challenges we faced. The EVM JSON RPC API is also very specific to the EVM. So it only really talks about addresses, blocks, and contracts and accounts, right? But what happens when your network does more than the EVM, right? Should you be forever limited to what the EVM does? It's also only gas-based in pricing, which again is good. It's a great decision. The EVM was smart in what it did. But all that it's saying is that it can only compute the amount of effort that the EVM does. But again, if the EVM is in another network, all the other work that the network does, the EVM has no capacity to basically appreciate that and express that in its API. So that was another challenge. The EVM also overfits for the 256-bit elliptic curve. This is actually something that Vitalik mentioned, that if he had the chance to do it again, he would probably choose the 32-bit or the 64-bit curve in that regard and add some considerations for more complex math. And this is a limiting function because for us, this was not a limitation before. The EVM also speaks about specifically ECDSA-based type cryptographic keys, right? And there's certain assumptions that are made here. Again, a great choice for the time, but something like this should have been configurable to other cryptographic types, especially when you think about the future of quantum computing and everything else. This is going to be a problem at some point in time. The KECAC 256 hashing is also another thing where it should have been configurable. For instance, Hedera natively was using the SHA-384, which is more secure. But again, great choice, should have been configurable. And then finally, everything that we're doing gets settled in Ether, which has 18 decimal points. This was for a good reason, but again, shouldn't be something that people are locked into. So with all these sort of implementation details, assumptions, and breakages, we at Hedera had to figure out, do we want to support the EVM? Do we want it to be compatible, or do we want it to be equivalent? There is this conversation about compatibility versus equivalence. Because of our user base, we thought that equivalence was the right way to go, and we didn't want to fudge things in the back, right? And you might ask, why did we do the harder thing? The simplest answer is our users were asking for it. You give your users what they need, right? And so we wanted to meet them where they're at. A lot of users have information, like you said, like yourselves, who have already understood the EVM. You've written smart contracts in Solidity. You've built up a lot of knowledge, and we shouldn't have to force you to learn a whole new API or a whole new language. We should be able to meet you where you're at. Again, we're all in the same Web3 space, working towards a greater goal, and we'll all make different decisions, but we need to be able to collaborate as well. So we decided to adopt the EVM so that we could speak that same language as many developers and builders and product owners out there. And ultimately, we also want to encourage open source contribution. In this way, we can have people who are already in the EVM space contribute to Hedera's open source, and Hedera open source developers can also contribute there. So now that we made this decision, I like this image because it's kind of early 2022, the journey that we set out on, right? You see this valley, it's not even, but you feel like it's trekkable, right? You see these large hills, you don't know what's on the other side, but you know you have to get above there, right? So this was the pursuit that we had ahead of us, and we decided to focus on 3 main areas: security, node features, and experience, right? So security is one of those things that when it becomes a problem, you wish you had done it earlier. So from past experiences, we decided to focus on this early on. So let me highlight a few things. The EVM has this really cool concept of an account can only modify its own account, right? The way it does this is by comparing addresses. So in that top layer, that green figure is URI. We take the wallet, we sign a transaction. We tell the EVM that we're trying to execute contract A. All right, contract A has some details about who the sender was, the address, the code in execution, if any value is being set, and other things. Contract A might call contract B, and you see the same thing. Contract B's context, it has to highlight to the EVM what code needs to be run, what state is being run, the originator, the sender, the value. These details are really important to ensure that the security of the EVM is enhanced. So if contract A tries to change something on contract B, it's not allowed because the sender is not contract B. However, what's interesting is that contract A at the bottom could be made to call contract B in a very interesting way. Some of you will know this as delegate calls, but you can run contract B's code in the context of contract A. So the business logic, or like what the Solidity code would do, will operate on contract A state. This is useful, but it can also be the place where a lot of security breaches happen. This is a little different than what Hedera does. Hedera initially says that you sign a contract or you sign a transaction, you have given authority over any changes that might affect your account, because the ownership should be on the user, right? So if contract A calls multiple contracts and they all do something on my account, by me signing, I've given authorization. We don't necessarily think of it, or we hadn't thought of it at the EVM sort of contract to contract layer, because again, we put the onus on the user or the person signing, right? However, not everybody looks into this. Not everybody takes a keen eye into what every single contract is doing. So we had to ask ourselves, what is going to be our security model? So what we did is, on the right, you'll see we had 3 levels: level 0, level 1, and level 2. Level 0, we said that we will honor the EVM security model. So an account, unless the addresses match up, will not be able to modify anybody else's contract, right, or anybody else's state. You can only modify it yourself. Level 1, we make exceptions for ERC capabilities. Some of you will know about, approvals. I can give you an approval to send some value from my account to somebody else. An interesting thing here is that we do this not only at the smart contract ERC level, we actually do this for our cryptocurrency as well. And that's something that many chains cannot do. Let me repeat that. Our native cryptocurrency, the HBAR, you can make approvals for that, even though it has nothing to do with smart contracts. Level 2 is the final one, where we add on the Hedera capabilities. For example, we have this function on Hedera that allows you to say that unless I have signed the transaction, my account cannot receive any tokens or any native currency. For some people, that's really important for them to lock down their account, right? And so this was a security model that we decided to use. Going over to the node features, we had a lot of decisions to make. One of them was the layer choice, right? L1 versus L2. we decided to go on an L1 to give people that native experience, that first-class citizenship there. We also had to choose an EVM client that matched. We used to use Ethereum J, we switched over to Hyperledger Besu to really allow us to push the forefront of EVM equivalents. Our EVM transaction API support, we decided to not reinvent the wheel, but support RLP encoding. So we do this really nifty trick where all we do is we take the RLP encoded transaction, give it as an input to a Hedera transaction, and then we feed it off to the EVM so that everything works as you would expect. The transaction ID is an interesting one. On the EVM, transactions are identified by the hash. Again, a good decision, but not very human readable, right? On Hedera, we provided a transaction ID that gives you some information about who submitted it and what time. And so on the back end, we make those connections so that EVM developers can still search for the transactions using their hashes, but also are aware of the transaction ID. We had to think really hard about key type support. The EVM only supports ECDSA-based type accounts. On Hedera, we support ED25409 as well as key lists and threshold keys. So you can say 2 of 5 people need to sign a transaction before it's going to go through. And so we had to figure out how to support both of these things. We exposed the concepts of blocks, and we also added free queries on the archive, as well as increasing traceability by exposing logs and bytecodes and state changes. On the account interoperability side, as I mentioned, we did EDDSA type accounts first, and the EVM does ECDSA. There's some interesting math that relates a private key to its address in the end. This was something that Hedera didn't need to do, but for EVM equivalents, we added it. So our account entity, we added a property called an alias, which will hold the EVM address. But also on the EVM, accounts actually don't need to be created. They're just addresses. But on Hedera, our accounts are a lot more complex. We did account abstraction before account abstraction had a name, right? We were able to add these properties. But to be able to support these creations, we added a new flow in which if you send any value to an EVM address, we'll automatically create the account on the back end for you. But if you decide to use the native approach, you can also specify the EVM address. We also expanded our token support. We have native tokens outside of the smart contracts that can be transferred at 10,000 transactions per second. But we said, why not hook it up and make it so that native tokens can be addressed as if they were ERCs. So our fungible tokens can be treated as ERC20s, and our non-fungible tokens can be treated as ERC721. And within a smart contract, you don't really need to care, and you shouldn't have to. We also had to focus really hard on the user experience, right? We brought all of this capability to the node, but we need to make sure that developers and users have it exposed. We didn't have a JSON RPC around that time. It was like sort of mid-early 2022. And so we added a JSON RPC that essentially acts as an abstraction layer on top of the consensus and mirror nodes that Hedera has. So to EVM tools and wallets, Hedera looks exactly like another EVM network. We're just complying there and making it so that developers don't have to reinvent the wheel or have to do any special cases. We also added things like, contract verification. Up until this point, you could deploy contracts, but you might not be able to see it. Again, we didn't reinvent the wheel. We looked in the ecosystem. We found out Sourcify was doing great work. We partnered with them, and we brought that functionality to the Explorer. And then finally, we kind of use this as a check-in point, right? This end-to-end flow of, I start from a wallet, I look at a faucet, I use some EVM tool I deploy. We use this process to keep checking how close and how much progress have we made along EVM equivalents. And you'll find out that EVM equivalents, that goal, it keeps moving because it's more than just the features on the node. It's also the developer and the user experience. So if a tool gets highly utilized by some people, like Hard Hat or VM or Foundry, in a sense, it breaches into EVM equivalents, and if you don't honor the expectations of your users, you're non-compliant. And so this was a good sort of litmus test for us to be able to see how far along we were. So looking at post-equivalence considerations, 2022, we challenged the status quo. We brought in a new EVM client. We added a JSON RPC relay. In 2023, we committed and re-strategized and really dug in our heels and were heads down on development. 2024, we were in full swing and we started to see integrations come along. The PIF and the Super oracles came along, Chainlink and Layer 0. We have the graph support as well. And in 2025, we're really going to push in and bring things to the next level. Some of those things are we're going to add dynamic token support. I had mentioned before that we have 15 million gas per second. That's just a limitation that we put in so that people wouldn't be confused. We do not have to stay at 15, and so we plan this year to expand that 30, 50, 100. The limitations are really out there to be seen, right? We'll be adding support for the Pectra hard fork as well, and then really pushing the boundary on our consensus node executions. We want more oracles, and we want more bridges. And so finally, our goal is to provide the best EVM experience and expose you to mind-blowing Hedera features, right? So if you want to learn more, go to docs.hedera.com, check out our HIPs, comment on them in GitHub, and check out hashgraph.com careers as well. We're looking for great engineers as well. Thank you very much.